What's going on, Science 7A students? This is we've got a lot to cover today, so we're going to really need to jump into it and get going. What I need to do with you folks is we kind of talked to you guys a little bit about this when we talked about when we did the orientation. And I talked to you folks a little bit about setting up the scientific method. In your book that's going to be coming up, they're going to throw out this word called a double-blind test. And I need to explain what that is to you today. So in this chapter, I'm not sure if you covered it or you will cover. I know for a fact you will cover it this week. I'm not sure if you've read it already. But Lei goes off and she does a double-blind test. And so I need to explain to you what that is. Cool? And today we're going to be covering the scientific method and really explaining this. Now I'm sure that you've covered this topic in 6th grade, but and I'll tell you what, I'll tell you what is I'm going to cover it with you in 7th grade. We're going to cover it with you in 8th grade as well. Hopefully by the time you reach physical science, chemistry, and biology and physics, you're going to have the scientific method down packed, because that's really important here. Got it?
Okay, we're coming in.
Okay, cool. So just to verify, everyone can see me? You can see my computer screen, or you can see my face? Awesome. And you can hear me? Okay, Titus, these things have windows, and these windows are a little bit interesting to play around with. If you can only see like a presentation and it says hypothesis on it, that's the one I don't want you to see. Minimize that window by pressing that small little line on the bottom left, right, or on the top right-hand corner. What I want you to see is the desktop sharing and the webcams. So make sure you make those windows so that you guys can see them. Let's get into scientific method and talking about that. Oh, and we have some guests here. They're from Japan, and so welcome.
Thank you.
Feel free to ask any questions if you have any while we're teaching. All right. Julian, I can't right now, but I will talk to him in just a second. All right. So the question is, what do scientists do? And to be honest with you, this is kind of a topic. The scientific method is something that we've been hammering into you for a long time now. But the crazy thing is it's taken like a couple thousand years to come up with this idea. And this idea of the scientific method, even though you might be familiar with it, is actually a relatively new concept when you look at all of human history. All right, what happened here? There we go. Awesome. So, the first thing you need to start off with the scientific method. All right, Isaiah. I've got some messages coming in from the other students. I need you to tone it down a little bit. I'm going to talk to you after class. Is that cool? All right, thank you. Yeah, I've got some students kind of messaging me about you, and so I'm going to make sure that I take care of that. All right? All right, you and I can deal with this on a one-on-one basis for now. And for now, why don't we leave it at that? But if I need to, we're going to have to call in your parents if that's going to be something that continues. All right, cool. Anyway, the first thing that we do with the scientific method is we start off with a question. And what I'm going to do is I'm going to let you folks run a lab, and it's going to be a quick lab. And that lab is going to be, for now, it's going to be a virtual lab. So we're going to start off with the question, something like, how does the color of a jacket affect its ability to keep you warm? If you have a black jacket, does that mean you're going to be warmer throughout the day than a cold jacket? Or not a cold jacket, a white jacket, or a yellow jacket, or a green jacket for that matter. So that's our question that we start off with. Scientists ask a question. Now, before the scientific method, let me tell you kind of a story. There was this guy named Aristotle. And Aristotle was this great philosopher back in the day. And what he did was he would ask questions, but the thing about it is he would ask questions and then he would say the only way to kind of get to the bottom of these questions is to talk about it and reason with it. They wouldn't experiment. That's crazy. In fact, there was this big thing between the scientists called Galileo and Aristotle. And Galileo said things like, things at different size objects fall at different rates. And Aristotle said, no, that's crazy. Why? Well, Aristotle said that's crazy because some other smart guy said that's wrong. And Galileo says, no, I'm going to experiment on this. And so what happens is you have this conflict between, I think, scientific authority versus scientific experiment. Does that make sense to you? And I think this is revolutionary in an idea. So what they did was, Galileo was kind of the founder of developing this scientific method. Actually, to be honest with you, it started off with this Arabic guy, which I can't pronounce his name right now. But a lot of these concepts come from like ancient Arabia. So what we're going to do is we're talking about the scientific method, and we're trying to ask the question, which jacket will be the warmest? And you folks have already given me some ideas. I got Keeley who's saying the white jacket is better in Hawaii. What else? What are your thoughts? Which jacket will be the warmest? Or give it to me in an if-then statement. If I wear a blank color jacket, then it will blah, blah, blah. Don't just tell me a color. Tell me, if I wear something, then this will. Yeah. I'll tell you what, folks. If you want, you can turn on your microphone and talk back to me. Wait a second. Why is my audio not? All right. Well, we're going to go on an individual basis. Isaiah, why don't you answer? Tell me, if I wear a blank jacket, then blah blah blah. You tell me. What is your response?
You mean as in blank as white?
Yes, exactly. The blank, I mean a color. This is your guess to our experiment.
If it's black,
Yeah.
it would overheat the pigment and the color. The black will absorb the sunlight, and the jacket will get hotter.
Okay. So that's your guess, right? We don't know if it's correct, but that's your guess for now. But you see, that's the thing. Is the next thing I want to talk about is this thing called a hypothesis. Oops. Oh, wait. Is a hypothesis. Now, wait. Somebody's calling me. Who's calling me? Yeah, you got to say your name because I've got like 5 people up on the microphone. Okay, what's up?
The color of the jacket depends on the heat of the outside, because the lighter of the jacket will really affect you.
Okay, so you're saying, so what you're saying is it depends on the material as well.
Yeah.
Okay, all right.
Wait, I know something.
Okay, who's that?
Juan.
Juan. Okay, Juan, give me your guess.
Digital voice. Darker the jacket, the more heat it attracts.
Okay, so what we're doing, and in fact, I want you to give it to me in an if-then statement, because what we're doing is we're creating a hypothesis for our experiment. We're giving our guess. We're saying, this is what we think will happen. So for this experiment, your guess, it seems like all of you have said, if I wear a darker colored jacket, then it will be warmer. Is that correct? Am I pretty much summarizing what everyone is thinking?
The pigment of the color, it gets absorbed to the light. I learned this in 5th grade.
Okay, you learned this in 5th grade. I'll tell you what. The best thing for us to do is to experiment with it. Now wait a second, it looks like my computer screen went out. Let me make sure that it's back up again. Give me a second. I know you can still hear me, but it looks like the server crashed for my my computer. Let me just re-up it. Give me a second. Okay, wait. So while this thing is still working on it. Okay. While this thing is still working on it, let me talk to you guys about this. What we did was we created a hypothesis. We created something testable. We can go in and sayonara. We can go in and test whether or not your your guess is correct. Now, one second. It looks like. Oh, wait a second. It looks like the network went down on this computer. I'm redoing the connection. I'm sorry, you guys. Sorry, folks, computer glitching. All right. The next thing we need to do is we need to run our experiment. Now, here's how the experiment will work. And while the network comes up, I want you guys to pull up the resource. I'm going to look it up real quick. Yeah, I know. It's because my computer went down. I'm reconfiguring the network here. I know. Give me a second. I know you can't see anything. Hold on. All right, one second. Glencoe. All right, here we go. I want you to click on this website while I get the computer to work again, okay? Well, actually, you can do stuff for now. I'll tell you what. Here's the thing. Look at this. Did you guys click on that website? And then I'm going to ask, yeah, I agree. Can everyone turn off their microphone except me? They wanted me to turn on the mic. I don't usually let you guys do that, but they wanted me to turn on the mic so they could hear you. This is the Japanese crew. But I need you guys to turn off your mic now so we can get through our lesson. Got it? Someone was asking me a question before you turn off your mic. What's up?
I actually have rules right now.
Yeah. Well, I'll tell you what. We don't need you to do the. We don't need you to test it right now because we can actually use our testing system, or we can actually use the virtual lab to test all of this stuff, and that's really cool. All right. So while this thing is pulling up, are you folks at that website that I gave you? Here, I'll give it to you again. Click on this thing. All right, so check this out. We can test one of these jackets. Okay, wait 1 second. Here we go. So you can either look at my computer screen, or you can, let's see, where's that thing that I had though? Oh yeah. You can either look at my computer screen. Actually, why don't you folks look at my computer screen for now, instead of looking at your own one, or instead of looking at the link that I gave you. All right, so check this out. What we can do is we have a heat source, and apparently our heat source is like a 60-watt light bulb, okay? And we're going to test out these things. Now, if we have a 60-watt light bulb in this testing environment over here, and we have a 70-watt light bulb in this testing environment here, is that a good thing? Is that all right? No. Why not? Why can't we have a 60-watt light bulb over here and a 70-watt light bulb in the other one? What's the problem with that? Okay, because they're different. They have to be the same. I totally agree. Because everything in this room, in this second room, will be hotter than everything in the first room because you have a higher wattage light bulb heating up the source. Does that make sense to you? So, so the problem. Oh wait. This thing is getting kind of annoying. Come on, computer, turn off the sound. There we go. All right. So what I'm saying here is you need to keep certain parts of the experiment the same. Does that make sense? We can't, if we're going to test these things side by side, we only want to change one thing. And that one thing that we want to change is like, or what is that one thing we're going to change? Okay, only Mr. Balde has his mic on, but what is that one thing that we're going to change? The color of the jacket, exactly. Am I going to have like long sleeve jackets over here and short sleeve jackets over here? No, because that might affect the experiment. Am I going to have like cheap thermometers on this side and expensive thermometers on that side? No, because that affects the experiment. Am I going to test maybe for 10 minutes on the left side and 5 minutes on the right side? All right. What you folks are saying is absolutely correct. We want to keep everything the same except for the colors of the jackets. Now, the colors of the jackets is the thing we're going to change, right? What is the thing that we're measuring? What are we measuring? Heat. Okay. The heat, I would rather say the word, it starts with a T. It's right in front of you, right here. Temperature, exactly. We're measuring the temperature of the jackets. Agreed? We're measuring the temperature of the jackets. So that is something that changes, right? And it's something that we're measuring. It's something that is a result. Now, the temperature, now this part is kind of confusing and a lot of people get mixed up with these concepts. The temperature of the jacket depends on the color of the jacket. That's what our experiment is saying. Write that down. Chat that back to me so I know that you heard it. The temperature of the jacket depends on the color of the jacket. Put that in the chat bar. Everyone do it. I'll say it again. The temperature of the jacket depends on the color of the jacket. All right, there we go. Good. Type that out for me. All right, awesome. Okay. So because the temperature of the jacket depends on the color of the jacket, we call the temperature the dependent variable. Why? Because that's what it depends on. It depends on something else. In an experiment, we have two different kinds of variables. One is called a dependent variable, and the other is called an independent variable. In our experiment, the dependent variable is the temperature. The independent variable would be the color. Exactly. There are other variables, but we call those controls. We want to try to control those variables. One variable would be the light source, the heat source. You'll want to control that. One variable will be the time that it takes for the thing to be for the experiment to go. You'll want to control that. Another variable could be the material that it's made of. you'll want to control that. You only want to have one independent variable. You only want to change one thing. That's important in an experiment. Because if I change something, if this were black nylon jackets and this were like blue wool jackets, that I wouldn't be comparing those two things. I would have more than one independent variable. My independent variable would be the color of the jacket and the type of material. That's a problem. So you only want one independent variable at all times. And the best way that I remember the difference between the dependent variable and the independent variable, or every single time I'm going to have quizzes where you guys are going to have to read an experiment and identify which one is the dependent variable, which one is the independent variable. The dependent variable is always the thing that you want to measure in the end. The independent variable is the thing that you want to change that will affect that dependent variable. Are we good? Does that make sense to you? And the controls are all the things you want to try to keep constant. You want to hold that still. You don't want to have that change. Okay, so let me show you how this app works, because it's actually a pretty cool one. It's very quick. So what we're going to do is I'm going to ask you folks to test all the jackets. You just take a black jacket and a blue jacket and you put it up there and you run the test. And the test will take 5 minutes, but then they accelerate it real quick. So it's like 5 minutes, done. And it will give you data. It will give you this information. I want you to write all of that data down in a table. All right? So I want you to write everything down in a table. Let's start making a table now. Let's see. I'm going to go to Drive. Oh, this is my wife's account. Yo, somebody's asking me a question.
Yes, people are asking me to mute my mic, but my computer is glitching, so it's not letting me move my mic up to the mute button.
Okay, that's just a tech issue, you guys. You guys are gonna have to forgive him for not muting his mic, because it's something he can't do right now. Is that all right with everybody else? You can try logging off and logging back in, but I mean, if you can't even mute your mic, I don't expect it to what you call it. I don't expect it to log you out and log back in. Just try not talking, so that way they can hear my voice. It's not that I don't want to hear your voice. It's just that yeah, it's just I think that right now they want to hear what I have to say. Anyway. Here's what I would do. I would put down like black wool. And then I would write down the numbers, 31.1, 30.6, and 30.6. Are we cool? And then I would go over to blue wool. And I would write down my numbers, 28.9. Oh no, my computer, did it die? I'm doing the class today in this odd room. I apologize. Anyway, go back to that website that I shared with you. And I'm just going to teach from there. I'm going to let this computer just be like, you know what, computer, you stink. Let's not talk to you. Anyway, I want you folks to try something for me. Okay? Pull in a yellow wool jacket, or you know what? Pull in a green wool jackets versus the yellow wool jackets. And I want you to run the test. And tell me what the numbers you folks get are. So type up the numbers for me. I want the green wool versus the yellow wool. Run the test. Type up the numbers like Titus did. Thanks, Titus. Now, Bo, I got a question. Why are you giving me one number? All right. It's not that you're in trouble. It's not that even that you're wrong. It's just because on my screen all three numbers were the same. Oh, I see. Okay. So you're giving me 28.3 for the green, okay? And then the yellow you got like 28.9 and 29.4 and 28.3 again. Okay. Do you folks know how to average numbers? Is that something you folks learned in 6th grade math? All right, type up for me, how do you average a number? Add and then divide. Exactly. Okay, so for the yellow jacket, if we were to average those numbers, those three numbers are different, right? So we would add up all of those three numbers. We would add 28.9 plus 29.4 plus 28.3. All right, 28.9 plus 29.4 plus 28.3. We would add them, press enter on your calculator, and then divide by 3. And in math class, we called that the mean, M-E-A-N. Have you heard of the mean before? Yeah, there's like 3 different kinds, right? There's the mean, there's the median, and there's the mode. Right now, we're interested in finding out the mean. It's the average. Or at least it's what most people call the average. All right, Titus, I got a question. What is this 86.6 that you threw up on the screen? No, 86.6 is not the average. I have a feeling that you added all 3 of those things up, but you forgot to divide by 3. I have a feeling that you added 28.9 plus 29.4 plus 28.3 up, but you forgot to divide by 3. Exactly, there we go. So divide that by 3 and tell me what the average for the yellow is. What did you folks get for the average yellow? 28.8666667. Okay. Huh. You want to know something interesting? According to our data, the green jacket is cooler than the yellow jacket. Huh. That's interesting. I don't know. I don't know why. It's interesting to me, but I don't know why. I don't know what the deal is with that. I mean, maybe that might be a small mistake. You know what would be interesting is if we test a different material. We compare the green nylon jacket to the yellow nylon jacket. Because that actually goes against our hypothesis. Or at least what we thought, at least our calculations. Hopefully we didn't do it wrong. Or maybe we should compare the green denim jacket to the yellow denim jacket. And we'll see what happens there. This is the kind of experiment I want you folks to run. You got it? All right, so I've got 10 minutes. I want to go over this concept with you. And I think that I have the time to do it. Give me a second. Sorry. Okay, wait 1 second. Let me find it. All right, give me a second. Let me try to find the thing I want to share with you. Here we go. All right, can you see my computer screen? You see Clever Hans?
Here.
Awesome. Okay, good. That's what I want to share with you. Okay, so we talked about an experiment. We talked about a hypothesis and then controlling the variables and dependent variable and independent variable. We talked about how to process data by finding the average. There's later on I'm going to show you how to find the range. That's really important in terms of like using math in science. From all of this, you need to draw a conclusion, but you can only draw a conclusion based on the data that you see. Now, there's this interesting concept that I think I have enough time to share with you, so I want to talk to you folks about this. Fair? All right. I wrote an article, or at least I kind of like copied and pasted from different sources to find this article. I'll share it with you folks. I'll put it inside of the class for you. Let's see. Let me just share it straight with you folks. Control C. Yo. Yeah, I suppose. So I'm just telling you right off the bat, this is not my own article. I didn't write this the entire thing. I edited it, but it's not just me. True that though. Don't turn in something like that to me. Can I? You're gonna ask me if I can mute people who can't mute themselves. You know what? We only got 10 more minutes. So let's just finish off the class. Is that cool? All right. So check this out. In the 1800s, so around like 1904, I think that was the year 1904. There's this dude. His name is Wilhelm von Osten. He was a German guy, and he's a German high school math teacher. He wasn't a scientist. He was a math teacher. Nice guy. I think he's super interesting. And he really liked working with animals. Particularly, he liked working with his horse that he named Hans. Now, he trained Hans to be, which is a horse, to have like math abilities, and this math abilities were crazy. Apparently, back then, this horse could do math problems. It could read math numbers. It could do things like okay. So if he held up the number 4 in front of the thing without saying anything, the horse would tap his foot 4 times. Or if he told the horse tap your foot 4 times, it would tap its foot 4 times. I know it's crazy, but I mean it would do even more crazy things than it would like spell its own name. What it would do is he would say, okay, well, let's let A be the number 1, and B be the number 2, and C be the number 3, and then the horse would tap his hoof to spell out the different letters, and it would spell his name. It would spell like Berlin, or the city it's in, or something like that. And so what this guy Olstein would do is he would go around and invite people to come and see this horse. I'll show you the crowd. He would go around and invite people to see this horse. Now, a lot of people were thinking, okay, this guy's a scam artist. This guy's like, tricking everybody. But I mean, I think this guy was like a relatively nice guy. He didn't charge any money. It never said anywhere in my research that he's charged any money to do this. He just did this because he thought it was really cool and really interesting and wanted everybody to see it, and everyone got really excited. Okay. Yeah, I would too. Anyway, he only made mistakes occasionally. His accuracy was about 90%. Basically, he did math. This horse did mathematics equivalent of a 14-year-old. How old are you folks now? Are you 14?
No.
Oh, then apparently this horse could do math better than you. Okay, so Naturally, naturally, I agree with everybody. You folks are saying, "Wait a second, this sounds crazy." You know, that does not sound right at all. So what he did, what German's Board of Education did, was they asked von Olstein if they would agree to put together a team to analyze whether or not um, this horse actually was able to do these crazy things, or if it was some kind of trick. So they came up with this thing called the Hans Commission, and the Hans Commission consisted of two zoologists, a psychologist, a horse trainer, a bunch of school teachers, and a circus manager. So they went in and they tested. All right. Now they concluded in 1904 that this horse was the genuine thing. This horse really had the talents to do the math problems. Okay. Well, I think that if it were possible to have these horses actually have these higher processing powers, it would give you kind of like a pause to how we treat horses, wouldn't it? It would kind of make you think, wait a second, we're kind of enslaving these intelligent creatures. We better give them a chance to vote if they're that smart. You know what I mean? I see what you're saying. I think there's a problem here. So anyway, they passed it on to this psychologist, and it's tough to pronounce this name. It's a German name. I'm not very good with German, but it's Oskar Pfungst. Pfungst. He's a psychologist. Anyway, what he did was he tried to come up with different ways to test this horse. So instead of having Oscar Osteen, the owner of the horse, ask the questions, he had other people ask the questions. And the horse still got it right. He had them do different things, but here's the thing that's kind of really interesting to me. When he would have the person who asked the questions stand far away from the horse would get the problem wrong more often. And I think that's really interesting. When he would have the people hide from the horse or stand behind the horse and ask the horse a bunch of questions, the horse would almost never get the answer correct. So what do you think's going on here? The horse got scared? Maybe. The horse is blind? No, I wouldn't say the horse is blind, because if the horse could see the person who is asking the question, then if the horse can see the person who is asking the question, then I would say the horse is definitely smart. The horse is deaf? No, the horse isn't deaf, because you could tell a horse, stomp your foot 4 times, and the horse would understand. He memorized a bunch of different problems. Now that would be very impressive. Still, I would be impressed about a horse doing that. All right, so here's what actually they figured out that happens. Okay, what Hans would do. Now, what Hans would do, the horse would do, is he would watch the person who's asking the question, and he would start tapping his hoof. And the person asking the question has never seen a horse do math. So as the horse would tap its hoof, the person would have these small, like, facial expressions to kind of get all excited when the horse is getting to the right number. And then what the horse would do is, when the person would start getting excited, the horse would, like, when the horse got to the right number, the person's face, even though they didn't say anything, face got really excited, and then the horse would stop tapping. So the horse never actually did math. He just watched everybody else get excited around him when he was tapping his hoof, and then when they all got really excited, he stopped tapping. Well, I don't know. I never asked the horse what he really wanted, but I mean, I'm just saying that that's probably what was going on. It was called the Hans effect. So what happened is they said, "Oh, okay." So, because I mean, this wasn't something that happened with just their owner, but this was something that happened regardless of who they had asking the question. People asking the question would get excited to see a horse almost get the answer correct, and they'd be like, "Whoa!" And then the horse would stop tapping his hoof, and then the person would blow their mind because they would be like, "Wow, this horse is so smart." So there's a problem with our experiment, isn't there?
I think I think what happened is when somebody got excited and noticed it and
Yeah,
something
yeah.
like that.
Because animals are very good at reading. I mean, animals read, I guess, which they call body language, right? Like they don't have a language, or at least I don't know the language that they speak to each other. So they basically are able to read they're able to read the body expressions that other animals give, right? So I'd imagine that animals are very good at reading even human expressions because I mean that's the language and how they communicate. So what happens is, maybe this horse wasn't good at math. He was just good at reading people. So here's how we fix that, okay? We performed this thing called a double blind experiment.
Teaching that.
And what we would do, yeah, we fixed that by teaching all horses math. No. We would perform this thing called a double blind experiment. And here's how we do that. We would, what if the person, Juan, we're almost done. Don't worry about Juan. I can ask him to turn off his mic. Juan, try not to talk or respond. Try to type in your responses. I apologize. But what we would do is we would run the experiment, and let's say that the person asking the question didn't know the answer. You know what I mean? What if the person asking the question didn't know the answer? Then the person asking the question wouldn't get all excited when the horse got close to the answer. You know what I mean? Like what if we gave a little kid who's like 7, who knows how to talk but doesn't necessarily know how to do math, a problem like 13 minus 8 or something like that, and the kid doesn't know the answer, and so then the kid says, "Clever Hans, what is 13 minus 8? Horse, what is 13 minus 8?" You know what I mean? And then the horse would tap his foot, right? But the kid wouldn't get all excited because the kid doesn't know the answer. You see what I'm saying? Now, I know you folks think about other animals, but I'm just saying about this particular horse. What if we did that? That would fix the problem, wouldn't it? So, from this idea back in 1904, we had this horse. We came up with this idea called the double blind experiment. And it's where the people doing the test don't know the answer. Because if the people doing the test know the answer, they might affect the experiment. And we don't want that. That would be another variable we're throwing in there. Does that make sense? That would be breaking our control. We want to have more control. We want to even have maybe even the people running the experiment not know which one is the correct answer. Because maybe they might say, well, is it which one tastes better, cup A or cup B? You know what I mean? Would they be like, is it cup A or is it cup B? Right? Because maybe they want cup B to have the maybe they're running a soda experiment and they're trying to say, well, which soda tastes better? Is it soda A or soda B? Maybe because their soda, the one that their brand they're representing, is soda B, and so they want everyone to choose B. You see what I'm saying? So what if even the experimenter, the person asking the questions, didn't know what the answer was? Then you would have a better experiment, and that is called a double-blind test. Because like a blind taste test would be you taking the labels off the bottle, so at least the person that the experiment is being done on doesn't know the answer. But a double-blind experiment is where both the person that the experiment is being done on and the person doing the experiment both don't know the answer. Yes. And so then there has to be somebody else who knows the answer. Maybe the original person conducting the experiment would get a bunch of their students to run an experiment, but they would have to, set something up. Or maybe they write down in a card which one is which. We'll talk about this later on Wednesday, and we'll get deeper into this stuff. But I wanted to kind of introduce to you this double-blind concept. So when you get to it in the book, you folks are like, oh, I understand what they're talking about. They're running a double-blind experiment. All right? So you folks have homework, and the homework is a lot of multiple choice questions on scientific method. Your homework is also, there's a lab that I have. I think I'm going to make that due next week, Monday. And the lab is, I want you to finish the lab that I gave you, the sweater one, the colors. You have a lot of homework due this week, and that's all from last week's lecture stuff. So I gave you a lot of homework on rocks and waves and those kinds of things. It's due this week. All right? All right, I'll talk to you folks later. It was good talking to you. Thank you folks for hanging out. And today was a little bit different. I apologize for the switch up, but, they ask me to do something, and I'll say, okay. All right. Okay, bye.